Greeting Earthlings! If you follow the channel, you know that we are hard at work restoring the Apollo communication hardware. It started over 2 years ago with the two main microwave communication boxes from the Apollo spacecraft, loaned to us by Steve Reverting. These are the transponder and the traveling wave amplifier that give you voice, data and television from the moon. They were marvels of microwave communication gear at the time, and I would argue that they still are. Then the project kept getting more involved as Steve, Marcel and other generous collectors supplied us with more and more genuine NASA boxes, plus a few we acquired on our own. We've now gotten enough parts that we can pretty much reconstruct the entirety of the very complicated S-band communication system. We ended up having to reproduce a portion of the Apollo control panel so we could control the whole unwieldy system just as the astronauts did. So far, our crowning achievement was the live demonstration of the system at the DesignCon conference earlier this year to a crowd of very appreciative electronic engineers. For the DesignCon demo, we had live up voice and up data from the ground, as well as live television and emergency Morse key from the spacecraft, all working on the original equipment. We were quite proud of our achievement. But the keen-eyed amongst you might have noticed that we haven't revived one important feature yet. We do have television from the moon alright and Houston's voice going up, but we don't have the voice from the astronauts in the down direction, a link that was aptly called the Downvoice. Actually, we did demonstrate Downvoice once, in episode 10, but with a modern SDR receiver. So at least we know the spacecraft side of the voice transmission is working properly, but we have not received Downvoice yet with our NASA receiver. The main reason is that our receiver had been modified after its Apollo days to support what we think was the GEOS 3 satellite mission. We already reverted the receiver to the Apollo carrier S-band frequency, but we must back out some more modifications further down the chain to extract the correct Apollo voice subcarrier. This is what we will attempt in this episode. So while Mike and Eric, show yourself.
I'm back.
There you go. Are trying to figure out the wiring to our control panel here. I have the enviable task of undoing one of the last modification that we didn't undo. They changed one of the carriers, the subcarrier filters here for the Atmospheric Explorer mission. And fortunately we have the good notes from Mr. Landsman, who tells us which caps and L's he changed in the filter back there. As a reminder, the Apollo Unified S-band communication system uses a plethora of subcarriers and nestle modulation schemes in order to simultaneously transmit many channels of information on each of the three main microwave carriers. This results in very complicated spectra that we explained and demonstrated in previous episodes. The link of interest here is the PM, or phase modulated downlink. In normal operation, this is the primary downlink which carries ranging, spaceship data and the astronaut's downvoice. In normal operation again, data is transmitted on the subcarrier at 1.024 MHz, shown in blue, while voice is transmitted on the subcarrier at 1.25 MHz, shown in green. These are then separated at the receiver end. We can clearly see the data subcarrier frequency of 1.024 MHz indicated on our NASA test receiver front panel. However, there is no 1.25 MHz setting for voice. It looks like it has been overwritten by a 768 kHz subcarrier instead. Obviously, the GEOS satellite needed no voice, so the Apollo voice equipment was likely replaced by data equipment that used another subcarrier frequency. The receiver was then modified accordingly. Fortunately, Dave Landsman, the engineer that did the modification left terse but incredibly helpful notes on each module that he modified. Oh man, it has 1, 2, 3, 4, 5, 6, 7 connectors. Alright. Very modular. Alright, so same classic construction as we had before, very pretty prototyping. Who needs a PCB when you can do this? So fortunately this is the one unit where we have the manual. So the filter of interest is this one, signal comes in, a one-stage amplifier, a second order filter, arranged in a pi configuration, and then another amplifier. So we need to replace those three caps and then retune L5 and L6 to 1.25 megahertz, which is the voice subcarrier. So it's not too hard to figure out because the output comes at J7 and this is J7, so I just go where that wire goes, it goes here. This is my amplifier and these are the caps in question, those three. This is L5 and L6. Okay.
Okay, Mark, do you think I should power this up and see what happens?
Why not? I am sort of doing the highly stressful rework job here, so I'm behind everybody else. Okay, so I reverted to the original config with 2 capacitors of the original value. Here I needed 12 puff, I didn't have one, so I took 10 puff and I added a 1 puff over there. Hopefully that will be close enough. So now I have to retune the whole thing, but fortunately I have the whole procedure. It calls for an HP606A instrument, and then with your HP 400D voltmeter, I have one actually, and your Tech 543B, you monitor the output and should be 1 dBm, and then you want a bandwidth at minus 3 dB of 10 kilohertz. But we have even better than those HP instruments. We have the tracker and the spectrum analyzer, so that will just make it a lot faster. Okay, so I have the tracking generator centered at 1.25 megahertz. So now I'm going to put that input to over here, and that should be the output of the filter. And I see nothing. Oh, center, the wrong center. Center 1.25 megahertz. Okay, so we're way off. Can I move this? It over. Man, I'm glad I do that with the spectrum analyzer. That's been a royal pain with the parameter. And here I can see exactly what's happening. There we go. And we are back. In the middle. go increase the span to 100 kilohertz, and then we want the reference level way down over here. Then we want 3 dB per division. dB, okay. There we go. Pretty much. I think that's about as good as we're going to get it. It's back to its Apollo sound carrier. Alright, so we'll consider it retune to Apollo goodness. And here is my little sticker telling that I put it back as it used to be at the time of Apollo at 125 megahertz minus 3 dB at plus minus 10 kilohertz. Okay, I hooked it up to the spectrum analyzer to see if I could get the noise. Oh, I do. So this is 1.25, this is 1.04, this is 500 kilohertz, 100 kilohertz, 10 kilohertz. Whee! I think we're good. No more 768 kilohertz. That was an eyesore anyhow. There we go. Oh yeah! 1.25 megahertz. That's what was hidden beneath. Save 4. There we go. Recall 1. Now you should be able to give me choose transponder 1, for example, workhorse. There it is.
See the signal?
And I'm receiving it. Alright, that went into lock. So now if I go recall 4, do down voice backups. Yeah, that's it. Yeah, and then do regular down voice. Yeah, we got regular down voice. If you talk into the thing, we might be able to see it jiggle.
Hello, 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 hello. Jiggle, jiggle. Nothing?
50 kilohertz. Huh. Why am I seeing that?
Talk, talk, talk. Hello, hello.
Okay, so we got something. I'm not sure why we're getting those spikes in the middle. That doesn't seem quite right. Okay, our wiring might not be good. We might have some self-oscillation somewhere. So here's our first attempt to get voice from the downlink. So once a 1.5 MHz subcarrier has been demodulated and extracted by the NASA receiver, we are not entirely done. As we explained in episode 10, Downvoice is transmitted as a narrowband FM modulated 1.25 MHz subcarrier, itself phase modulated onto the S-band PM downlink at 2.2875 GHz. All this techno-babble is a complicated way to say something really simple. The Apollo Downvoice is an FM radio transmission from the Moon, which has been conveniently relayed to Earth by the S-band microwave link. Now that the 1.25 MHz subcarrier has been extracted by our NASA S-band receiver and its retune filter, we are left with the original FM radio transmission. We need an FM radio that can tune all the way down to 1.5 MHz to listen to this very interesting FM broadcast. Fortunately, my humble ham radio receiver can do just that. Note that we are not the first ones to do this. A few well-equipped radio hams succeeded in eavesdropping on the astronauts' communications during the real missions. There is an asterisk to this, since microwave equipment was very far out of the reach of real amateurs, so they all were professionally involved with microwave communications on top of being radio hams. So they borrowed a parabolic antenna and an S-band receiver from the university, government or industry lab they were working at, and then hooked up their ham gear equipment, just as we will do here. I'm hooked up to video. Output video is 1.25 megahertz, which is the voice carrier, goes into an attenuator, goes into my ham radio, tuned at 1.25 megahertz and on FM, so I should be able to receive it. There's nothing, so I have noise. So we got something, but we didn't get what we wanted. We're having this complicated spectrum, and it should be just one line. I see one line of sideband and more of that. And if I look on my HP spectrum analyzer, I see the exact same thing. And on top of that, I can hear it. I can hear a 10-ish kilohertz tone. And if I talk into it, it's not gonna work. Hello. Very distorted. With our tones. Hello. Can you hear me? So something's not right here. Uh-oh, something's cheesy. To debug it, I took the microwave radio transmission completely out of the equation by listening to the 1.5 MHz subcarrier straight off the box that generates it in the spacecraft, the PMP. Okay, so we simplified it a little bit. I am taking it straight out of the PMP and going into my receiver. And Mike, if you turn the voice, go for it. There you go. There it is. And then we hear this disturbing tone. Can you say something in the microphone or send me a tone?
Hello.
Yeah, we hear you.
Yeah.
Okay, so something's still not working.
Soon after.
We think we figured it out. We were suspecting something from the CTE, and the CTE gives the reference frequency.
Flashback.
We dealt with the CTE, which stands for Central Timing Equipment, in episode 25. It provides the mission time, of course, but this complicated box also generates a 512 kHz reference frequency for the communication system, which is then used by the PMP to generate the subcarriers, including our voice subcarrier. It also has a 6.4 kHz output, which is used to drive the AC power inverters. It's a box that we disconnected when we moved the equipment to Design Con, and I have an inkling that it might not have been reconnected properly.
End of flashback.
And sure enough, when I scoped the reference frequency going into the PMP, it looked like it was getting the 6.4 kHz for the inverter instead of the 512 kHz for the subcarrier system. That's the old rocket wiring switcheroo, which has killed more than a few real space missions. To confirm that this was indeed the problem, I used my trusty HP generator for the 512 kHz instead of the CTE. So now if I remove the CTE, so of course it's not driven anymore, and use that to clock it. Works better, 512 kHz. Oh, that's much better. And that's much better. Give me some voice or some beeps. Okay, that was it. So we were doing the wrong output, and I think the mistake is mine. I misclocked the connector here. So our homemade connector doesn't have a key, and I installed it wrong. It must be from DesignCon. And then we never bothered because we weren't doing down links.
The numbers should be marked on the connection itself on top of the connector.
Yeah. Woo! Much better.
Yeah, looks like we're back.
You got it. Turn the.
Go ahead
Okay.
and say something.
Hello.
Oh, beautiful.
How are you?
Alright, much better. Voice comes out okay from the PMP now. Let's reconnect our microwave radios. Since you insert stuff in the right direction, we'll use your mic. Okay. Which doesn't want to run. There it goes. Panel operator. Give me transponder 1. Oh, is the PMP on? Oh yeah, I see it. Huh. Okay. It's... Oh, I need to lock it. So I need to turn the transmitter on.
That looks really cool.
And it's... What is it doing? It's trying to lock it. There you go.
Wow.
We got it. See something?
Downvoice.
Oh, that's via radio now. Okay. Excellent. Then now, a voice. Hello.
Hello.
Hello. Oh, it's working both ways?
Yes.
Alright, excellent. 13, this is Houston.
Go Houston.
If you could do a stir to your cryo tanks.
No.
Okay, fine, we'll stay away from steering our oxygen tanks, but we got Downvoice working, which our guest Usagi Electric immediately put to good use. We are far from done with this though, as the receiver will give us a good scare and need further repairs. We'll add our own FM demodulator so we can free up the ham radio for other fun uses. And then it's on to data demodulation. So stay tuned and see you then.